Hi, Year 11. I am still at home, but you are hopefully in school on this Monday, and we're going to continue with our formula use. This is concluding a kind of algebra section for this week. This stuff comes up in the HSC quite a lot, the medication, the blood alcohol content, so we need to be on top of this and keep coming back to it. So it's related to medication, what we're doing today. First thing we want to look at is there are a number of formulas that help to calculate how much medicine to give to a child. Obviously, it goes without saying, but children are smaller than adults, generally speaking. And so the younger you are, the smaller you are, and so the smaller the dose. But it's not always a direct half the dosage if you're half the size, for instance. You might need less. Depends. And there's other factors, developmental factors. Not every part of a child develops at the same rate. So we need to be careful in giving medication and follow the advice carefully. And so here are a few formulas that are given in the book. There's Freed's formula, where it's age in months times adult dosage over 150. Notice this is from 1 to 2 years old. All right, 1 to 2 year old, which is months times the adult dosage in milliliters typically, but it can be any unit actually, because it will give the same unit as your output. All right, so age of that's only for 1 to 2 years old. Now the Young's formula is the next one. 1 to 12-year-old is this one. Again, this one does the age. I'll let you think about what the problem might be with any formulas that use age as the kind of basis. This is age in years, and of course there's a lot of variation unless you get more accurate from 1 to 2 or 1.5. We'll look at an example of that. But what's the problem if you have an age-based formula versus the last one, which is Clark's formula, which is weight? But Young's formula is age of child in years times adult dosage over age of child in years plus 12. All right? And the final one is Clark's formula, which is child's weight in kilograms times adult dose over 70. All right, so again, just like we're looking at blood alcohol content formulas, there's no foolproof thing. These are work on average for people. Most medications have some margin of error that you get away with. But, in certain high-powered, more kind of potentially dangerous medication, doctors are very careful to get a good sense of the child's mass or their weight, make sure that that's all true. So let's have a go at using these ones. So we're going to use each of the three formulas to calculate a 1.5-year-old child's dosage if an adult takes 30 milliliters. Okay, so let's do Freed's formula first. Freed, I'll put that, Freed. So we've got D is equal to MA over 150 is the abbreviated version. We've got to be careful to know what it is. So it's age in months. So 1.5 years, I'll put that over here. 1.5 years is equal to 18 months. That may be helpful to know. So we're going to have dosage is equal to 18 times 30 milliliters, which is adult dosage, over 150, which is equal to, get our handy calculator out and work it out. And if we do that, we get 18 times 30 divided by 150, we get 3.6 milliliters. All right, which is quite a small amount, but you need to give a small amount to medicine in small cases. Okay, Young's formula, let's try that one. So that one is D is equal to YA over Y plus 12. Now, Y, of course, is in years. Now, years, we're going to do 1.5. So in this case, the dosage is going to be 1.5 times the adult dosage of 30 over 1.5 plus 12. All right. So, that's fine. 1.5 times 30. 1.5 is the year in age in years, times 30 over 1.5 plus 12. So 1.5 times 30 divided by, we get 3.333. 3.33 milliliters. Quite close, actually. It's fairly similar, which is good. And then the last one is Clark. Oh, and I didn't put his weight. Clark, we need the person weight. 1 child's dosage Uh, weighing a 1-year-old. How much does a 1-year-old weigh? Let's say 12 kilograms. Oh, that's too heavy. Let's say about 8 kilograms. All right. So let's say they weigh 8 kilograms. So this one's going to be D is equal to, we go up the top a bit, Ka over 70. K being the weight in kilos. So D is equal to, if they weigh 8 kilos times 30 over 70, which is equal to 8 times 30 divided by 70, 3.42 for 3 in this case, milliliters. Now you see all three are fairly similar. The question, of course, is which one is better to go to? I guess it depends whether your child is kind of average according to the growth charts. If your child is particularly small or particularly big, then you need to consider the weight more than the age. But if your kid's within an average range, then you might be okay to use the other ones. Now, usually, dosage, or my experience anyway, dosage of medication, and I haven't used a lot of medications for my child, but usually things like Panadol, Nurofen, they go by weight. And they say, within this weight range, give this much. And so, it's not a incredibly precise science, but in this case, it gives us the same. So essentially, you got to think, is my child within the average range? Any particularly large kids, very large for their age, tall and big, you might give them more and look at the weight rather than the age. Okay, let's move on to the next part of this, which is not so much using formulas, but we're talking about dosage rates. Now, when you're in hospital, if you've been to hospital, you would know about this. You get fluids, usually intravenous, IV, intravenous drip, and they have to be careful to give you the right amount. You have to be, depending on your weight, your size, what condition you have, you can get medication through it. You need to get hydrated, you get nutrients through it, so you don't have to eat if you can't eat. It's given over a period of time, and that's all to do with the rates, milliliters per hour, liters per hour, milligrams per minute, etc. So we need to be careful how we do rates, and often it's given as drops. So we want to look at that. So first question of an example, calculate the flow rate of milliliters per hour if a patient needs 7.5 litre of fluids in 10 hours. So the way we do this, I'm going to do the answers in blue. 7.5 litres per 10 hours. Now, if we get 7.5 litres in 10 hours, then I need to divide by 10 for 1 hour. So what we get is 0.75, well, I was going to do it in blue, well, no, it doesn't matter. 7.75 litres per hour. Now, what's 0.75 litres? Well, 0.75 litres is 750 milliliters. We times that by 1,000 to change to milliliters. And if we do that, we get what's required, 750 milliliters per hour. All right, so you see what I did. I divided by 10. The second part, I divided by 10 to get the amount of liters per hour. Then I multiplied by 1,000 to get the number of milliliters per hour. That's just, the volume is the same, it's just different units. Okay, so I'm changing the time by dividing by 10 in this case, and I'm changing the volume units, capacity units, by multiplying by 1,000. So we get 750 milliliters per hour. Let's try the next one. Calculate, now this is where it gets a bit interesting. You're saying, well, drops is what we need to set. Those little valves on the side of the IV, you can set to drip more quickly or drip slower, and the nurses come and set it. And that's how they know that it's giving a certain amount. So there's a certain number of drops per milliliter. And then how quickly the drops go gives you a certain amount over a long period of time. So this question says, calculate the drops per minute required if there are 15 drops per milliliter and a volume of 1.5 liters is to be delivered over 6 hours. All right, so there's a few rates going on here that we need to consider. So basically the first thing you think is, okay, well, let's not worry about the 6 hours for the moment. I can deal with that at the end, right? I can divide by 6 to work out, all right, how many drops per hour and then how many, but we need to work out, okay, how many drops are there in 1.5 liters? How many drops drops in 1.5 liters? Is essentially the question that I'm asking myself first. So there's 15 drops per milliliter, 1.5 liters. So let's have a think. 1.5 liters is equal to, well, we multiply by 1,000. That's how we convert it to milliliters. It's 1,500 milliliters. So in this case, there's 15 drops in every milliliter. So we multiply by 15. And so 1,500 milliliters in this case is 225,000, I think it is. 22,500 drops. Okay, 22,500 drops is the number of drops the person needs for the volume of 1.5 liters. Okay, that's the first thing we've worried about. Now we start to think, okay, what about this 6 hours business? All right, so the person needs, now I don't have to worry about liters anymore, or milliliters. I just worry about drops because finally I want to get my drops per minute requirement. So basically what we need to get is 22,500 drops. The first number I need is in 6 hours. All right, so that's equal to, well, let's divide that by 6. 3,750 drops per hour. Now, dividing by 6 because I've got 6 hours. Now I want to know how many drops I need. You're giving it regularly. So we divide by 6, you get that in 1 hour. Now I want to know, well, how many do I give per minute? Well, 1 hour has how many minutes? 60 minutes. So we need to divide that much by 60. So we divide that by 60 because there are 60 minutes in 1 hour. So if we do that, you get 62.5 drops per minute. Now, interestingly, this is approximately 1 drop a second, isn't it? It's 60 seconds to a minute, but that's just an interesting observation. Note, it's very close to 1 drop per second. But that's just an aside. But that's the answer here that we've calculated. So notice what I've done. Firstly, let's worry about converting the capacity that the person needs to drops. And then we say, okay, we need that many drops in 6 hours. And then you divide by 6 in this case, and then we'll go per hour. So then we divide by 60 to get per minute. So now I've got my drops per minute requires 62.5 drops per minute in this case. All right, let's do one more question, similar but slightly different. Last one. Calculate the time taken to deliver 600 milliliters of fluid delivered at 15 drops per minute with 10 drops per milliliter. Okay, 15 drops per minute with 10 drops per milliliter. And I need to deliver 600 mils. All right, well, let's first, now we're going the other way. So we want to first think about, okay, how many drops are there in 600 mils? All right, how many drops in 600 mils? Once we work that out, then we can do all the calculations we need and be able to do that. So because I know that, okay, 15 drops per minute, so we can work all that out. So how many drops in 600 mils. So this part of it actually is very similar. Notice the first one did how many drops in 1.5 liters? We're asking the same question here. Just the final thing is going to be not a rate, but it's going to be a time it takes. How many drops in 600 mils? Okay, well, what do we have here? 10 drops per milliliter, and we've got 600. So 600 milliliter times 10 drops. So 6,000 drops in 600 milliliters. That's what we have. This is an important number here. Now we're saying, well, how long will it take to deliver this? Well, the rate we're interested in is 15 drops per minute. 15 drops per minute. So when we working out the time taken to deliver something, think of the 6,000 drops as your distance and 15 drops as your speed. So time is equal to distance over speed, right? Essentially what we have. So therefore we have t, the time is equal to your distance, which is what you're trying to get to, which is 6,000 drops over 15 drops per minute. And that's going to give you 400 or 40. 400, I think. Let's double check that. I'm having a brain snap at the moment. 400. So 400 minutes is what we have. And so that's equal to, well, that's equal to, divided by 60, but it's going to be 6 hours. 6 hours. And that gives you 360, 6 times 60, 360, 40 minutes. 6 hours and 40 minutes to deliver 600 mils. So it happens very slowly. I mean, the hospitals, they don't pump you full of drug. You know, they have to go quite slowly in these drips. And so it takes quite a while to do that. All right, so 10 drops per milliliter. Look what we did. We said, okay, well, the total delivered is 6,000 drops. 15 drops per minute. Okay, well, 6,000 divided by the drops, that gives us 400 minutes. And so that is 6 hours and 40 minutes. All right, let's have a go. It's 3G, 1 to 16. Have a good day. Bye.